Hi guys, my name is Samantha and today I'll be explaining how to do number 4 on the AP Calculus AB test from 2016. So this problem belongs in section 2 and part B of the test, where there are a total of 4 questions and you are given 60 minutes, meaning you should spend about 15 minutes per question. Also, you aren't allowed to use a calculator for these problems, so be prepared to carry out simple algebraic calculations. For question 4 on the test, you are given the differential equation dy over dx equals y squared over x minus 1. There are a total of 3 parts to this problem, and part A is asking for you to sketch a slope field for the given differential equation at the 6 points indicated, and you're given a small coordinate plane in the first quadrant including the points 0, 0, 0, 1, 0, 2, 2, 0, 2, 1, and 2, 2. Points at x equals 1 don't have an existing slope because when x equals 1, the denominator of the fraction becomes 0, creating an undefined slope. To find the slope at each point, you would take the x and y values and plug them into the given equation to find dy over dx, also known as the slope. For instance, at the origin, just plug in x and y as 0, bringing you to 0 squared divided by 0 minus 1, which would result in a slope of 0. Then you take the n value and use it to sketch a small dash mark at that point, which would represent the slope. Continuing on, plug in the other 5 points into the original equation and plot each slope on the graph provided. In the end, your slope field should have a total of 6 dash marks where the slope is 0 at the origin and 2, 0, which would make sense because when y equals 0, the slope should also equal 0 except when x equals 1 because that would lead to a slope of 0 over 0, which is indeterminate. At 0, 1, the slope would be negative 1. At 0, 2, the slope should be negative 4. 2, 1 has a slope of 1 and 2, 2 has a slope of 4. The scoring guidelines break this part down into 2 points, where one is given to 0 slopes and the other is given to non-zero slopes. Overall, number 4, part A is pretty easy as long as you don't plug in the numbers wrong or plot them wrong. Personally, I believe that finding the slope values is pretty easy, but I have previously plotted the values wrong on the slope field, which made me lose a point on a test. So I recommend you compare your calculated values to the graphed values in the end if you have time. Part B states, let y equals f of x be the particular solution to the given differential equation with the initial condition f of 2 equals 3. Write an equation for the line tangent to the graph of y equals f of x at x equals 2. Use your equation to approximate f of 2.1. So this part is slightly more complex than part A and asks for 2 different answers, one being an equation for the tangent line for the graph at x equals 2, and the other asking you to use the equation you generated to approximate the y value produced when x equals 2.1. To create an equation, you need the slope and a point. To find your point, you just have to use the initial condition where x equals 2 and y equals 3. Next, to find the slope, plug in x equals 2 and y equals 3 into the original equation, which would produce 3 squared over 2 minus 1, which ends up being 9. Given your slope and your coordinate point, you can create an equation which would turn out to be y minus 3 equals 9 times quantity x minus 2. To answer the second part of the problem, asking to approximate f of 2.1, all you have to do is substitute x with 2.1 to find y, which would result in 3.9. The breakdown of this problem includes the tangent line equation and the approximation value, each 1 point and making a total of 2 points that can be earned for part B in number 4. Part C is asking for you to find the particular solution y equals f of x to the given differential equation with the initial condition f of 2 equals 3. Part C is the last part of number 4 and contributes to most of the points in this question as it has a total of 5 points you can earn. I find this part the trickiest, but only because it requires you to go through several steps to reach your final answer. Since you are given dy over dx equals y squared divided by quantity x minus 1 and have to find y equals f of x at 2, 3, just separate the variables until y's are on one side and x's are on the other side so you can integrate both sides afterwards. When you move like variables accordingly, you should have dy over y squared equals dx over quantity x minus 1. When you integrate 1 over y squared, you would get negative 1 over y. When you integrate 1 over x minus 1, you can use u subs to substitute x minus 1 with u, which would eventually lead you to the natural log of absolute value x minus 1 plus c. Don't forget your plus c because you are integrating an equation. After integrating both sides, plug in x as 2 and y as 3, which would allow you to solve for c, which ends up being negative 1/3. Return to your equation where you didn't substitute x and y values and plug in c as negative 1/3. From there, just rewrite the equation until you get y equals 1 over quantity 1/3 minus natural log of x minus 1. You may have noticed that the absolute value bars were omitted from the natural log expression, and this is because you already know that the initial condition would result in a positive solution when x equals 2. Being the longest part to number 4, part C can be broken down into 5 points. The first point is for separating the variables. If you miss this step, you will automatically get a 0 out of 5, so you could consider this the most important step even though it only carries 20% of the weight for this part. The antiderivatives are worth 2 points, the constant of integration, also known as c, and the use of the initial condition where f of 2 equals 3 are worth 1 point, and the final point goes to solving for y. Notice that you can only earn a maximum of 3 out of 5 if you don't add plus c. So if you're looking for more practice for questions like number 4 on the AP Calculus AB test, I found a few that require the same skills as number 4 that you can access that are all from previous Calculus AB AP tests. I meant to say access, by the way. Anyways, the first one is number 5 from 2011. Part A and C of this question are nearly identical to Part A and C on number 4, respectively. Part B is a little different because it asks for the second derivative, but still offers very good practice. The second one is number 6 from 2013, where Part A and B are pretty much the same as Part B and C from number 4, respectively. The third one is number 6 from 2014, where Parts B and C require the same calculations as Part B and C on number 4, but Part A from 2014 is slightly different yet mostly related. The fourth one is number 4 from 2015, where Part A would be good practice for the concept needed in Part A from 2016. Finally, the fifth one is number 6 from 2015, where Part A is similar to Part B from 2016. I'll link all of these resources in the description below and on this screen. Thanks for watching, and hopefully this video helped you understand how to do number 4 from the 2016 AP Calculus AB test, and good luck in the future. Bye.